This is the second in a series of videos on properties of basic functions, and then this one we're going to look at y equals x cubed. And the first thing we can do when we're looking at y equals x cubed is we can compare it to y equals x squared. Well, if you think about y equals x cubed, you can just do a table if you wish, x and y equals x cubed. And let's plug in 5 values. Let's plug in 0, 0 first. We already know that that's going to be a special point. 0 cubed is going to be 0. And then let's plug in 2 and 5, minus 2 and minus 5. So 2 to the third, that's 2 times 2 times 2, that's 8. And 5 to the third, that's 5 times 5 times 5, that's 25 times 5 is 125. Now let's look at minus 2. That's where it differs from x squared. Negative 2 to the third is going to be a negative 8, and minus 5 to the third is minus 125. So let's graph that, and let's compare it to x squared. If this is x squared, x cubed is going to be a little steeper in the positive direction, but it's also going to go in a negative direction too. So that's the basic graph of y equals x cubed. And let's talk a little bit about that graph. So you have y equals x cubed. You have an important point here at 0, 0. It's not a vertex anymore, but it still is an important point. Later we'll call it the inflection point. It starts off flat, but it gets steep pretty quickly. And then it's a mirror image across the origin, so it goes in a negative direction. So that's y equals x cubed. And let's start with the attributes. Now if you start with the attributes, the first thing you're going to do is find domain and range. Right here are the attributes here. First thing we're going to do is domain and range. And domain and range are both very easy. They're both going to be all real numbers. So if you want to do an interval notation, it's negative infinity to infinity, and the range is minus infinity to infinity. In other words, x can be anything and y can be anything. So that's domain and range. The next thing we're going to look at in terms of an attribute is continuity, and it's going to x cubed is continuous at all points. So when you're asked about the continuity of a function, you're asked, is it continuous at all points, or are there places where it's not discontinuous? The next attribute we're going to look at is where is it increasing or decreasing. If you notice, if y is always increasing, right? So it's increasing always. Or you can say it's increasing over the interval minus infinity to infinity, which is another way to say everything. Let's look at some more of the properties or attributes of functions. If this is y equals x cubed, let's look at boundedness. There's no lower bound because it continues to go negative, more and more negative, and there's no upper bound because it goes more positive. So we say the boundedness, the way we generally say that is we say it's unbounded. Extrema, there's no local minimums and no local maxes. No mins or maxes, local or global. So you can just say no mins or maxes, or you can say no extreme. The symmetry is that this is an odd function. In fact, this is a good way to memorize odd functions because this is the most basic odd function. If you need help trying to figure out if functions are even or odd, then watch the video on even and odd functions. There are no asymptotes. So if we think about that, let's to review real quick. We have one more to go. The domain and range are all real numbers. It's continuous at all points. It's increasing at all points. It's unbounded. There are no extrema. it's an odd function, and there's no asymptotes. The last one is in behavior, and we're going to draw in behavior in limit notation. So if this is our graph right here, let's do the in behavior. So we go limit of x cubed as x goes to minus infinity, and limit of x cubed as x goes to positive infinity. Let's see what happens. As x goes to positive infinity, y goes to positive infinity, and as x goes to negative infinity, y goes to negative infinity. And those are the properties of y equals x cubed.